Lab 5. Choose Your Own Adventure Lab. The objective of this lab was to observe emotion from daily life and model it using VPython. I chose to model a person shooting a basketball into a hoop, and then calculated the drag force that would be necessary for the ball to fall into the hoop if it were given an arbitrary initial velocity. The fundamental principle in this lab is Newton's second law, which I used to find the various velocities at different time periods and create my model. The other principles that were necessary for this lab were the gravity force, which is negative mg times j hat, which gives the gravity force the direction, and the drag force, which I used, and the equation I used for the drag force was negative b squared, and b represents the drag constant. Here's my tracker file. Here's the ball being thrown into the basketball hoop, and as you can see, I set the axis to when the person stopped lifting up with his knees so that the motion of the ball would be accurately represented. So I made 3 different codes to model the actual movement of the ball, the movement of the ball at an arbitrary velocity, and a code that calculated the necessary drag force constant that would make the ball fall into the hoop. This section here is the system's properties. I've initialized the mass of the ball, the initial position, the initial velocity, and this is where I read in the CSV values from a file. This file contains the ball's position and this data was extracted from the tracker file. This is the loop that calculates the velocity and the position using Newton's second law. Here I calculate the force of gravity using negative mg. And the assumption I make in this is that gravity is the only force acting upon the object, so the net force is equal to the gravitational force. Here I use Newton's second law, and I find the velocity at different time periods. And using that velocity, I calculate the position of the ball, and then use the trail.append function to graph that motion in Python. Here's the code when it is run. Here, one thing to note is that I'm using 2 black spheres right here to denote the ends of the hoop. And in this motion, the red ball is the motion of the actual ball extracted from the tracker file, and the motion of the blue ball is the one created by Python. As you can see, the motion of the basketball is recreated very closely with the Python code. For the initial value in the Python code, I used a trial and error method to find a value for the velocity that closely matched the motion of the basketball from the tracker file. In the second part of the code, I chose an arbitrary value as the ball's initial velocity, and from this we can see that the ball overshoots the hoop by a dramatic distance. The red ball still represents the original basketball and still falls into the hoop. Now, I wanted to use my code to predict the drag force necessary to make the basketball fall into the hoop. In the physics part of the code, I need to add in the drag force. Here, W represents the weight force or the force of gravity, which is just negative mg. Here's where the drag force is. And for the equation of the drag force, I use B times the magnitude of the ball's velocity squared. Since in this model we are assuming that the drag force and the weight force are the only 2 forces acting upon the object, and these 2 forces act in opposite directions, so we need to subtract it. So the net force is the force of gravity minus the drag force. Here's the ball's velocity using Newton's second law, and the position of the ball, and then we use the ball's position to create the trail in the Python code. Here's the code with the drag force. Let's run it. Now, as you can see, with the drag force, the ball does fall into the hoop, but not with the same path as the original one from the tracker file, because the new code takes into account the drag force, but it also begins with a different velocity, so its path will not be the same. Now, if the velocity were changed so that it was the same as in the basketball from the tracker file, then the ball would not even reach the hoop because the drag force would work against the motion of the ball.